So this is a JavaScript conference, but I'm quite sure that many of you here have experience also with Node.js, or that at some point you had to do some Node.js in your life. So I want to start with a Node.js example here. And it's about copying files or copying data from one place to another. And when you do that in Node.js, I've seen many times people doing something like this. You just include these libraries, these functions from the fs module, read file sync and write file sync. Then you have a source and a destination. You read the data from this source using read file sync, and then you write it to the destination using write file sync. So this is good. We do this all the time, and it's OK. But sometimes, and that sometimes is probably the worst moment in your life when you're doing something very important, or you are sleeping, or you are on holiday, this will happen in your production application. So the file size is greater than the possible buffer. And in order to understand why, allow me to give you an amazing analogy, including Super Mario. So please, if you do work for Nintendo, don't sue me. OK, so imagine that you are Mario and you have bytes, and these bytes are the blocks here. And you have to move these blocks from one place to another. So what happens is that if you give Mario only 4 blocks, he has enough strength to move them all in one go from one place to another. But if you give Mario too many blocks, of course, he doesn't know how to do them all in one go. So what can we do to help Mario to move all the blocks to one place to another? And essentially, we can move them one by one, which means we are streaming these blocks from one place to another. And today, we're going to talk about streaming in Node.js and then how to use the same ideas in the browser. I am Luciano. I guess at this point, you know, or you kind of guessed already that I am Italian. My accent, Super Mario, and everything else, my name as well. But I live in Ireland, in Dublin, where I work for an American company which is called Vectra. And what we do at Vectra is essentially network security. We do automated threat detection using AI and machine learning. We also build a number of solutions in the cloud to help security team to troubleshoot security issues and figure out why specific attacks were possible. So if you're curious about this stuff, please come to talk to me afterwards, or you can connect with me in my social channel and ask me any question about that. Also, as Simona mentioned, I am happy to say that I've been the co-author of this book. There is also an entire section dedicated to streams, so if you happen to read it, please give me some feedback. All the slides are already online. I'm going to show you a lot of code examples, so if you want to get the slides already so that you can look them in your mobile phone and maybe spend some time in more slides to ask me questions later, you can do it. Also, all the examples are on GitHub, so please get all these links. I will tweet them later if you don't have time to scan the picture now. So let's go back again and talk about the difference between a buffered approach and a streaming approach. We used before this functionality called read file sync, and to really understand what it does, essentially you can see here that every time you use that functionality, all the content of the given file will be loaded in memory in this data structure that is called buffer, which represents all the data in a binary format. When you instead use streams, and you can do that in this case with the create read stream function, what happens is that you get another abstraction that is actually called the stream instance. And this instance is lazy. It's not going to load all the data in one go. It's just going to load a little bit of data, wait for you to consume it, or help you to consume it in different ways, and then move the data on. So you only load fractions of the data every single time. So if we want to re-implement this copy file functionality from the buffered approach to the streaming approach, it's very simple. We just have to replace few functions. So we now import create read stream and create write stream. Then we use those two functionalities to create the stream instances, so the source and the destination. And then we can use this interface that says, every time there is new data available in the source stream, call this callback, and inside this callback, I get the data, and I write it to the destination stream. This implementation is not perfect. I will tell you exactly why later on. But for now, it's a good abstraction to understand the idea of streaming. So that data there is never all the data in the file, but it's just pieces of data that you can move over time. So if we want to understand what is the memory implication with the two different implementations, you can use, for instance, the Chrome tools also to see and debug Node.js scripts. In case you didn't know, this is awesome. So if you do that with the buffered approach and you try to copy a file that is about 600 megabytes, you can see that the maximum amount of memory allocated is about 600 megabytes. So at some point, you have all the data in memory is taking 600 megabytes of your RAM. If you compare the same implementation using streams, and you still copy 600 megabyte file, you will consume only about 3 megabytes of memory maximum. So you can see already that there is a huge advantage in terms of memory efficiency there. We know already, because we saw it before, that if you try to copy a file that is even bigger than 600 megabytes, let's say gigabytes, it will explode with the buffered implementation. But if we use the streaming implementation, it still works, and it's still going to consume roughly 3 megabyte maximum. So you can see now why streams are a much better idea than just buffering everything. But just to summarize better this concept, so with streams you get kind of a lower memory footprint, so generally better. But there is another very good advantage there, that is with streams you can start to process data as soon as the data is available. And just to go back to the Super Mario example, imagine that Mario also has to paint every single block in blue. What happens with the buffered approach? Moves all the blocks, and only at the end you can start to paint all the blocks one by one. Instead, if you are streaming, you can take one block, paint it in blue, then take the other block, paint it in blue. So you can start to see results early on. You don't have to wait for every single step to finish before you can start the other step. So there are different types of streams in Node.js. So I want to show you what are the main ones and what are the APIs you can use to deal with them. But before doing that, let me tell you that every stream instance is just an event emitter. And if you have been using JavaScript and Node.js, you are definitely used to this concept, where essentially you have objects. These objects can just fire events, and some other piece of code can listen to those events and do something with the data that is coming from the event. So it's a very reactive way of thinking about how the program unrolls. So the first type of streams I want to describe to you is readable streams. And you can see readable streams as input, so an abstraction over some data that you want to consume. And I already showed you the example of readable streams from the file system. But if you're doing a console application, even the standard input can be consumed as a stream. If you're doing HTTP application, you have some stream functionalities there. You can read the data in a streaming way. And also, if you're using, for instance, the AWS SDK and S3, you can read files from S3 as a stream. So you can read very big files without having too much memory issues. There are two different ways to consume readable streams, flowing and pause mode. I'm just going to describe today the flowing mode, just because I think it's the easiest and probably the most common. So a readable stream in flowing mode more or less looks like this. You have these three elements. The first one represents your actual source of data. Let's say it's on a drive with a file system. Then you have this instance in Node.js that represents the stream, helps you to load the data from this file. And then eventually you have your business logic, where you will have some data listener that is waiting for the data to arrive. So when you create when you have those three entities, the flow of data looks more or less like this. So you create the stream. As soon as you create the stream instance, this stream is going to start to consume the data from the source and store it internally in its own memory. And you have different chunks. And as soon as one chunk is loaded, that will be sent to the data listener with a data event. So inside the data event, you will have all the data for that specific chunk. And this will go on and on and on until all the data is consumed. And at that point, there is another event that is called end that is sent to the data listener to indicate that all the data has been consumed from source. So I want to give you a more practical example and a very funny one. Imagine you have text files and you want to know how many emojis there are in a specific text file. I'm using here a library from NPM that is called Emoji, so you can use that. It's amazing. You can get all the emojis. And then what I'm doing is essentially using this primitive that I just described before. As soon as I have a readable stream from the file system, I can say on data, and I know that with that data comes the current chunk. A chunk is nothing else than a buffer in Node.js, so it's some binary data. And in this case, I'm just saying, since I know it's a text file, so it's going to be strings, I can read every single character as UTF-8 and checking if that character is an emoji using the library. Then what I'm going to do is just attach a few event listeners there at the end to check, OK, when it's finished, actually tell me what is the current counter. So if you run this code against this amazing emoji art, that of course is a tribute to Ireland, you will see that in this file there are 37 emojis. And of course you can use this even with gigabytes of data. It's just going to work and it's going to be very efficient because of the streaming model. So another abstraction is writable stream, and it's kind of the opposite idea of readable stream. So if readable streams represent input, writable streams represent output, so destinations where you want to write your data. And again, I already mentioned the file system, but going back to the command line, you can have standard output and standard error as writable streams. Also HTTP again, if you are writing requests to a server, you can do that in a streaming way. And S3 as well, if you want to create a file in S3, you can do that as a stream. So I have here an example that allows you to use the bare bone HTTP module from Node.js. So I'm not using any special like requests or Axios or other libraries to do HTTP. And this will give you streaming primitives. So when you do this HTTP request, will return you an object, which is essentially a writable stream. And on that object, you can attach a bunch of events to understand how the state of the stream evolves. So when it's finished, when the connection is closed, if there was an error. And then at that point, you can start to write data on that stream, which means you created the channel, you are making a request to the server, and you can start to write data on that channel. And you have two methods to do that. The first one is write, that you can call as many times as you want to keep writing more data. And the other one is .end. And this .end, you will call it to say, this is the last time I'm going to write. After that, please close the stream and consider the request completed. So I'm just saying, writing some content, and then last write and close the stream. If you run this on the client side, so if you just run the Node.js script, this is what you're going to see. Request sent, server responded with 200, and connection closed. But if you want to observe it from the server side, this is what the server is going to receive. And you will see that the body of the request will be writing some content, last write, and close the stream. Now imagine that you can use the same idea to transfer big files. You can keep appending more and more data without having to allocate that all in one go. And the server will receive the first chunks of the data immediately without having to wait for you to load all the data and then send it all in one go. But every time we talk about streams, there is this specific keyword that always comes up and is a bit scary, that is called backpressure. And I want to describe it with an analogy. So imagine that, going back to the example of copying one file from one place to another. Imagine that you have two different drives. The first one is very, very fast, like an SSD drive. The other one is slow, so either a network drive or a magnetic disk. And while you're copying the data, of course, you're going to be very fast at reading, but you're going to be slower at writing. So on the writing side, you will keep accumulating data. And which means that if it's too slow, eventually you will accumulate 10 gigabytes of data in the 10 gigabyte file example. So it's not efficient anymore as we wanted. So backpressure is something that allows us to deal with that. And in the Node.js streams, you have ways to figure out if you are essentially overloading the destination and you have to stop. So when I told you that that first example wasn't perfect, this is why, because we were not dealing with backpressure. We were just writing more and more data. So if you were using that in two different disks with different speeds, you might end up with this issue. So if we want to re-implement that in a better way, dealing with backpressure, we can do something like this. Every time you call .write in your destination stream, you will get back a Boolean, and that Boolean essentially is telling you if it's safe to keep sending more data or if you should stop because you are overloading the destination. So I'm calling here this variable can continue, and then I'm basically saying, if I should not continue, I want to pause my source stream, which means I'm not going to read any more data until it's safe to keep writing again. But how do we know when it's safe to keep writing again? How do we know when the destination is flushing all the data to the actual disk? And we can do that by listening to an event that is called drain, that comes from the destination stream. And drain means, OK, I flushed all my data. Now it's safe for you to start sending data again. And with that callback, we can just say, source stream, you can restart and keep reading data. So we are dealing with backpressure. And it's not difficult, so much wow. Of course, there are other types of streams. The most famous are duplex and transform stream. You can see duplex stream as a combination of a readable stream and a writable stream together. They are very, very good, for instance, when you want to represent network pipes, so channels where you are both reading and writing at the same time. And also there is a special type of duplex stream, which is transform stream, which, again, it's a combination of readable and writable, but looks more or less like this. So you write data on one side, the data inside the stream gets changed or transformed somehow, and then when you read it on the other side, you are not reading the original data anymore, but you are reading a transformation of that data. If you're wondering how is that useful, for instance, gzipping, so you can say, I have this transform stream which essentially is able to gzip whatever data I'm going to write into it. So I can write data that is not zipped, it's going to take care of gzipping it, and then on the other end, when you read the data, it's already gzipped. So with this concept in mind, you can combine this operator in our copy file example, and you will copy file and gzip them in real time. So I already described you APIs to do listen for data on one side and write it on the other side. So you are already thinking, okay, now I have three components, a source data, a transform stream, and a destination stream, right? What do I have to do to actually combine them all together? I'm adding a listener to the first one and saying, when there is data, write it to the second one. But also I have to add a listener to the second one and say, when there is data here, write it to the third one. And also you have to deal with back pressure. And this is all the code you end up writing. Like a lot of code. I don't expect you to even read it. And I'm going to tell you I'm not even handling error here. So it's like dangerous. It will be even more code if we keep adding all the error handling. So this is not good. Seriously, there must be a better way. Otherwise, we wouldn't be talking about streams today. And of course, there is a better way. And it's called the pipe operator. And the pipe operator is super simple. And it looks like this. So essentially, when you have a readable stream, you can just say .pipe and pass to that function another stream. And that stream can be either a transform stream or a writable stream. And you can combine multiple call to pipe and do multiple transformation, and eventually you're going to write your data somewhere. This will take care of creating for you all that on data events, all the writes, so you don't have to worry about all these things. It's going to handle back pressure for you, and it's much more user-friendly. So if we want to write this code that takes some data, gzipped it, and write somewhere else, we can just do this. Like source stream, pipe it to a gzip stream, and pipe it to a destination stream. This is much better, I think, and easier, so probably you don't do silly mistakes by writing a lot of code. And this is actually the most common way you will see people using Node.js streams. And for instance, here, you have more complicated pipelines where you are reading data from somewhere, for instance, S3. You know this data is compressed, but also encrypted, so you have to decompress it and decrypt it before you can actually do some transformation. And then maybe you want to store it somewhere else in S3 and has to be encrypted and compressed again. So you can build this pipeline in a very declarative way by using this pipe functionality. Of course, nothing is perfect in this world, so there is a problem with this. And the problem is that this API, every time you say pipe into something, will return you a new instance of a stream, which essentially means, okay, this is the stream that represents the two previous streams combined, but now since it's a new instance, you have all sorts of different error and events handlers that have to be attached there. So to actually do proper error handling, you would have to say on error in every single step of the stream, because you will get different instances. And this is super ugly, but also complicated, because in your error handling function, you might want to deal with the error, but also destroy the streams, also close any potential, I don't know, file pointer or resource that you might have opened. So it gets very complicated to handle all these errors together. So yeah, seriously, we don't want to do all of this. Otherwise, we don't want to use streams at all. And there is a better way also to solve this case. To talk about that, I'm going to introduce a specific stream utility that is called stream pipeline. And stream pipeline essentially will allow you to do the same thing that we were doing with the .pipe with a slightly different syntax. So we can just say pipeline, then we can pass a number of streams that we want to be piped together in the specific order. And then at the end, we can pass an extra callback, and that callback is going to tell us that when the stream is finished, either because there was an error or because all the data was moved from one place to another. And when there is an error, this is actually the important part, this implementation will take care of destroying all the resources that were allocated in all the streams. So you don't have to worry anymore about dealing with every single step individually. So here you just check if error do something, otherwise it means everything was fine. So I really recommend you to use this functionality. It's by default in Node 10, but there are libraries that will allow you to do that if you are using previous versions of Node.js. Then there is another very good utility that is called readable stream. The name is a little bit misleading because it's not just the readable streams, you actually have all the streams code in there. And essentially, if you get the last version of Node.js, for instance, today I think it's 12.1, there will be a specific implementation of stream. Of course, the stream package has evolved over time. So with this code, you are sure that you are using a specific implementation. So you decide which version you want to use. So if you don't know what is the runtime you're going to eventually use to run your application, you should be using this module to be sure you are essentially using a compatible implementation of streams. And now let's move on to the last topic, which is we have been using the default stream, so HTTP, file system. What if you want to write your own custom streams? And I'm going to give you a kind of realistic example if you want to be silly. So you want to stream emoji to the browser. And by streaming emojis, I mean that one element is an emoji with its own description, for instance, emoji lemon and lemon. Then we want to do a transformation step. We want to make this description uppercase. And then finally, we want to write this data into the DOM. So if we have another element, it's going to do all the steps, and eventually it's going to end up in this list in the DOM. So the package readable streams is going to give us different classes that we can extend to implement all these different types of streams. The first one is readable. So you can extend this readable class. And at that point, you have to implement that _read functionality, which is basically telling the implementation how to consume the data at source. So in this case, we are going to use it to read data, emojis from an array, for instance. Then there is the transform stream, which is something you can extend and redeclare this method called _transform. Here you have to, you receive 3 parameters, chunk, encoding, and done. Chunk is the actual data that is passing over the different step at this time. And done is a callback that you have to invoke to say that you finished to do your transformation. So you can also do asynchronous transformations there. And then finally, the writable is very similar to the transform one. Instead, you have to write the _write, and you get the same type of inputs there. And another important element is that inside all these functions, you can use the this.push data to send data from the current step to the next step. So let's implement the first readable stream. Again, I'm using that emoji library. Now I am requiring the readable class from the readable stream library. And then I am extending this readable. Also here, since I want to keep track, I have an array of emojis and I want to keep track of what is the current emoji that I have to emit. Of course, I have to allocate an index somewhere, the current index. So I'm doing that in the constructor, and when you have to implement a constructor, just remember to call the super constructor and pass the options there. So people using your custom stream can still pass specific stream options like, I don't know, the buffer size and all these kind of things. And then I'm implementing the _read, where essentially I'm just doing 2 things. If I reach the end of my array, which means the index is bigger than the length, then it means everything is done. I can just push null, which means the stream is finished. Or if something in between, I just push the current element and increment the index. So super simple stuff. The transform stream is even simpler. Again, we import a class from this package. We extend that class. We implement the transform method. And here, what I'm doing, I'm just saying, I'm going to push this as a string and make it uppercase. And then it's done because it's just a synchronous operation. I don't have to do anything asynchronous here. The writable stream is super simple as well. You will receive, you again, import a class, extend it, and now you create this _write method. You will receive a chunk, and that chunk will be a text with an emoji and some uppercaseified text. And essentially, we want to display that inside a list. So we have to create a DOM element, and then we add the text, and then eventually we append this DOM element into another element called list. So we are essentially adding more list elements every time we are going to write something. And finally, we are going to invoke DOM. So how, of course, this is a browser example. How do we use this code that is obviously written for Node.js into the browser? And first of all, how do you use it in general? Like, how do you combine these 3 different streams? And it's super easy. You just import them. You create instances for every type of stream, and then you just pipe one to another. I could have used here also the pipeline, but it was just easier to do that because I know in this case there will not be errors like I'm not able to read from an array or stuff like that. And then, of course, you have to do some step to transpile this code with something that works in the browser. I'm using here a lot of requires, so how do you transform those requires into something that the browser can understand? And in this example, I'm using Webpack, but you can use Rollup, Browserify, whatever you like, it's going to work. And last piece that we need is some HTML that is going to wrap this code and also is going to expose the list where we want to append our items. So I think I have time to show you a very quick demo how this is going to look like. This is already rendered, but if I reload the page, you can see that elements get added one by one. In reality, this will be much faster. The code that I show you is not actually the code here. Here I'm intentionally slowing down the stream so that you can see the effect, and also adding some CSS animation so that you can see the elements being appended one by one. I don't always use emojis, but when I do, it should be with streams. So just to finish up, streams are amazing, in my opinion, and especially good if you have to worry about being very memory efficient, or if you have application where you are not sure what is going to be the amount of data you are going to receive over time. Maybe you are starting very, very small, so you are not that concerned, but you know that eventually you might have to deal with huge amounts of data. It's better to just implement straight away a streaming solution. Then the other good thing about streams is that you can process data as soon as it's available, so you can start to have early results, rather than waiting for every single step to be completed. So you can also deal with infinite streams. So if you are always receiving data and it's never ending, this is actually the only way you can produce results on the other side. And then the other thing I really like about streams is that they are an amazing abstraction. So you can create those pipelines and you have very clear building blocks. So you can see readable streams as input, transform stream as your main business logic where you are describing how to process the data, and then eventually you have writable stream to write this data somewhere, maybe a file system, a database, or even the DOM in my example. And if you are curious to learn more about streams, I can promise you there is a lot more to learn. So I already mentioned the first book. The second one is also an amazing book, very practical for Node.js developers. And there is as well a chapter dedicated to streams with all sorts of best practices. And then the third book is more generic. It's not a Node.js book. If nothing else, there are Java examples, so a little bit scary there. But it's going to teach you a lot more about the mindset of processing stream of data. So it's an amazing book, super interesting. So if you are still not convinced, or if you are sleeping, allow me to wake you up with this example. I don't know if you've ever seen this before. So you can just do a curl there, and this will happen in your terminal. So this is actually implemented with Node.js streams in a way that I find very original. But I think it will, if you go and check out the code on GitHub, you will understand how much powerful it is. And you can do all sorts of things with that. So please go and check out the code there, and you will be amazed about what you can do with streams. So if you are sleeping now, please wake up and go use some streams. Thank you.